So what we're going to do real quick is go over synthesis reactions. Before we go over synthesis reactions, I want to remind you of our Brinkelhoff, or our diatomics. And so if you remember, there are 7 elements: bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine, that when they are in their elemental form, meaning when they're not in a compound, they will exist as 2 atoms bonded together. They will never exist as a single atom. This is important because we're going to be using it quite a bit in our synthesis reactions. And so synthesis is when we have 2 components, usually elements, but it could be a compound or a polyatomic, come together to make a single compound. So for example, on this first one, magnesium and oxygen. I have my magnesium, and it's a solid. When I bring it together with my oxygen is one of those special diatomics, and so oxygen is going to be O2 because it's not bonded in a compound. When they come together, they're going to make magnesium oxide. Magnesium is a +2, oxygen is a -2, and so it will just end up as MgO. If you need help on how to write formulas, see my previous video. In this case, my oxygen is a nonmetal, and so it'll be a gas. Magnesium oxide, this is an ionic compound, and if you remember from previous lessons, an ionic compound is formed when there is a high attraction, and that high attraction causes those atoms to bond together and make a unit cell, and our unit cell is neutral overall. Then those unit cells stack and make a crystal lattice, and that crystal lattice is so stable that it is solid. Next, with our potassium chloride, let's go back for a second. I'm sorry, I forgot to balance. And so when I look at this, because of my diatomic oxygen on my reactant side, I have 2 oxygens there, but only 1 oxygen on my products. So to balance that, I'm going to have to put a 2 in front of the MgO. Now remember, you can't just put the 2 down here. The subscript 2's balance charge, not atoms. And so after I balance the charges, after I write the formula, I can only add coefficients. So now I have my 2 oxygens, but I also need 2 magnesiums. So I'm going to put a 2 in front over there. And now I have 2 magnesiums on both sides. I have 2 oxygens on both sides. I'm balanced. Potassium chloride. I have potassium, which is a solid, it's a metal, plus chlorine. Chlorine is another one of my Brinkelhoff. That's going to come together to give me potassium chloride. Potassium's a +1, Cl's a -1, so they're balanced. That means that just like above, I need to balance out to accommodate for my diatomic. Now the last one I have doesn't have a diatomic, so not all of them are diatomics. This time I have an aluminum, which is going to be a solid. I snuck my state scripts in up above there. I always have to double check myself. And then I have sulfur. Sulfur is going to be a gas. Sulfur is not diatomic, so it will just stay as S. However, when I come over here to write my formula, aluminum is a +3 and sulfur is a -2. So that means it's going to have to be Al2S3. It's still an ionic compound. It's still going to form the crystal lattice, which is solid. To balance then, I need 2 aluminum over here, and I need 3 sulfur. And now I'm balanced. Hopefully this helped. If it did, and you'd like me to keep making videos like this, then please click the like button so that I know it's worth my time. Otherwise, have an excellent rest of your day.